This is part 2 of lecture 3, electric circuit fundamental laws. The first thing we're going to explain series resistors. The series resistors that when the resistors are connected in series, as you see in this diagram. So the equivalent circuit will be the total resistance, the sum of these resistance. Example, if you have 5 resistors, you have 20, 20, 20, 20, 10 ohms. So if we ask about the equivalent resistance, so you will add them. So we have R equivalent is equal to the total 20 ohm plus 20, 20, 20, 10. And then you add them, you get 90 ohm. Then if you want to calculate the resistance, you can replace the whole resistance by only one resistance, which is equivalent 90 ohm, and the voltage source 9 volt, that's the plus, the minus, so the current will be in this direction. The current in this circuit will be equal to the voltage supply, which is equal to 9 voltage, divided by the total resistance 90 ohm will be equal to 0.1 ampere. Okay, what about when you have the resistance equal, they are equal, you don't have to add them, you just multiply by the number. So we say that the R equivalent in this case is equal N times R. N is the number of the resistance, 1, 2, 3, N is equal 3, and each resistance is equal to 20. So it will be equal to 60 ohm. Easy. Okay. There is an application to use it as a voltage divider. What does it mean that we use it as a voltage divider? We want to take part of the voltage, not the all voltage. So if you need this application, it's very simple. All what is supposed to do, connect to resistance in series. So that's, the input voltage, and that's the resistance, and that's another resistance. This is R1, this is R2. Current will be in this circuit. How can you find the current? You find the equivalent resistance. The equivalent resistance, R1 and R2, they are in series, so the R equivalent is equal R1 plus R2. And the current in this case will be equal to the voltage divided by the R1 plus R2. That's the value of the current. If you want to take the voltage across this one, that is the V out. So you multiply the current by this resistance. So the voltage out would be equal to the current times R2. I is equal Vn over R1 plus R2, and this is R2. Rearrange the equation, you'll be R2 over R1 plus R2 times Vn. That's the V out. So simply, if you want to find the voltage across any resistance, you put this resistance here in the top and R1 and R2 on the bottom, multiply it by V input. That's the voltage divider. Let's take one example, numerical example. You have here the voltage is equal to 12 volts battery, and you got R1 equal 10 and R2 is equal 20. You want to find the voltage across R2. That will be simple. We'll say that the output voltage is equal to the total voltage is equal to 12 volts times the resistance across which I'm going to take the voltage output, which is equal to R2 is 20 ohm, divided by the total R1 and R2. So it will be 12 times 20 over 30, 0 cancel, by 3 is 1, by 3 is 4, 8 voltage. So here I have 8 voltage. So obviously if this is 8 voltage, and that's the voltage supply is 12 voltage, so you will have here 4 voltage, because the total voltage will be equal to this one according to Kirchhoff voltage law. Okay. What happened now if we have the resistor resistors in parallel, like this one, R1 and R2. To find the equivalent, if you have only two resistors, this is a special case here. You multiply R1 and R2 and divide it by R1 plus R2. That will give you the value of the resistance. You multiply divided by the sum. Example, you have here 20 ohm, you have 30 ohm, you want to find the equivalent resistance. What does it mean, equivalent resistance? It means, you want to represent these two resistors in parallel by only one resistance, like that, are equivalent. So according to the formula I just explained, for two resistors only, R equivalent equal R1 times R2 divided by R1 plus R2. That's 20 times 30 divided by the sum. That will be 600 divided by 50, 12 ohm. So you can replace these two parallel resistors by one resistor only equal to 12 ohm. There is a special case. When you have two resistors in parallel and both are equal, is just divided by the number. So the R equivalent here will equal to R divided by N. Each resistance is equal to 30 ohm, and you got two in parallel, which is equal to 2 N equal to 2 only resistance will be equal to 15 ohm. So you observe that this is opposite to the series. When you have series, you multiply NR. When you have parallel, divide it by N. What happens if you have more than two resistors in parallel? You cannot say R1 times R2 divide. You can't say R1 times R. No, you can't do that. It has a special thing. You say 1 over R equivalent is equal 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Let's have this example. You got here R1 is equal 20, R2 is equal 30, R3 is equal 40. You want to find the equivalent resistance. You replace all these three parallel by only one resistor. I'm going to use the formula because there are more than two. 1 over R1. R1 is equal to 20 plus 1 over 30, 1 over 40. And you can do it in the calculator. Okay, you can do it in a calculator, easy. But I do not have a calculator now handy, so I'll just do calculation. So I'll find the common denominator, if you remember that. What's the common denominator? Okay, I will say the common denominator would be something like that. Okay, so that's the common denominator. That's 1 over 20. So you divide it, multiply this by 6. 6 times 1 is 6. Plus, I multiply here by 4, in the top by 4. I multiply it here by 3. I got here 3. You don't have to do what I'm doing. You can do it in the calculator fast way. I just want to finish it. So you have 120, 3 and 4, 7, 7 and 6, 13. That's 1 over R equivalent, equal this. So R equivalent would be equal the opposite, would be 120 over 13 ohm. You can simplify it in the calculator. Okay. Now, what happens if you have equal resistance? Will be just say, as we said, it was divided by N. So the R equivalent in this example will be equal to 1, 2, 3, 4. We got here 4, and each is equal 10 kilo ohm. So the answer will be equal to 2.5 kilo ohm. And it's done. Current divider. Current divider, it's different than voltage divider. Here we divide the current. This is the total current entering this node. So the if I sketch it in a different way, I will just can make it like that. Like, you have two branches. You have resistance here, you have resistance here, and then there is a current total going here. So it distribute I1, I2. But observe something here. The voltage across R1, it is the same across R2. That's different than the voltage divider. Voltage divider is the opposite. Okay, so if the voltage here, and that's R1, if you divided V by R1, you get I1. So you have I1 is equal V divided by R1. The same voltage applied to R2 because this node is the same. So the same voltage. So I2 equal V divided by R2. What is I? According to Kirchhoff current law, that's input will equal the sum of the output. So you will have I total is equal I1 plus I2. What's I1? V over R1, and I2 is equal V over R2. So if you have a common denominator, will be R1, R2, right? And you have here R1 plus R2 multiplied by V. That's I. True? Okay. Now, if you want to find any I, if you want to find I, for example, I1, or want to find I2, so what's I1? I1, as you know, is equal V over R1. Equal V, so equal V over R1. According to the equation we just got, I is equal R1 plus R2 over R1, R2V. Okay, you can replace V by the equivalent of current. So what is V? Is equal I times R1, R2 divided by R1 plus R2, all divided by R1. Excuse me. So when you cancel R1, R1, so I1 is equal R2 over R1 plus R2 times I. So let me say it in a simple way. If you want to find I1, you multiply the total current by the current in the other resistant, which is R2. Again, you want to find I1, you multiply the total current I by the resistant, the other resistant, which is R2, divided by the sum. And let's do I2. If you want I2, you will say is equal the total current times I2 passing in R2, the other resistance is R1, you put it in the top, divided by the total R1 plus R2. So this is the way that you remember. I1, you multiply the other resistance by the total current divided by the sum. Okay, let's just take one application. That's the voltage, and you have R1, R2, and you want to find any I. The first you got to find R total. How you find R total? But to tell you the truth, I mean, if I have this question, I'm going to solve it. I'm not going to do the current divider, because I mean this is only voltage, and this voltage I divided by, I can find I1. That's very simple. I would say it's equal to 36 voltage divided by 2 kilo ohm. That's equal to 18 milliampere. If you want to find I2 will equal 36 voltage. I'm sorry, this is voltage divided by 8 kilo ohm. Okay, so and you find the value, but you apply the current divider if you know the current and you don't have the voltage. I will give you one problem to think about it, and then we'll solve it in the lecture when we meet. If you have something like that, let's say you have 36 voltage and you have 2 kilo ohm, you have 2 kilo ohm, you have 8 kilo ohm, and you want to find the current here, I1, I2. I will leave it for you to do it, but I mean if you have it like that, you don't have resistance here, you have the voltage, it's easy. Why you go through the current divider? I just divide the voltage by the current. Why? Because this voltage is the same apply to this resistor and this resistor. But now in this case, it's not, this voltage is not applied to this resistor or this resistor. Why? Because there is one here in series. So surely this resistor will take some voltage out of the 36, and I don't know how much left here. So that's, I mean, the way that will do it. So I will let you think about that, but this is easy to find I1 and I2. Okay, here is a nice problem here. Find the current and the voltage. Okay, that will be a good test for the current and the voltage. Let's see first, IB and IA. What is the relation between IA and B? Since it's in series, so it should be the same one, equal. You can't have in the something in series current in this direction and current in this direction. So IB has to be like IA. So if you call IA going like that, okay. So IB is equal to minus IA. Because it has to be the current in this direction, the same direction has to be like this direction. So IB is equal minus IA. It means equal minus 2 ampere. See, the answer is very simple, just we got to do. Okay, what's IC? We'll do a very simple node or Kirchhoff current law. This current IA is coming from here, right? So there is current here, which is IA 2 ampere. And there is ID going in this direction, or going in, that's 1 ampere. So you got here node. So the total input equal total output. What is the input of this one? IC and this one. So we'll say IC plus 1 ampere equal the output 2 ampere. So what is IC? Equal 2 minus 1 ampere. So you got IC is equal 1 ampere. IC is equal 1 ampere. We did the node. If you want to find the voltage, it's simple, because it's required for you only to find VC. VC is equal the VC here. If there is a resistance, you multiply by I, but you don't have, so you got to find any loop. There is loop here and there is loop there, but I will just I will take the easy one. The easy one for me, I believe, this loop. Only 2 elements in parallel, so the voltage here and the voltage here are equal. Why? Apply Kirchhoff voltage law. Kirchhoff voltage law, I will just I'd like to sketch it in the way that I taught you in the beginning of the lecture. That's VD. What is the positive and negative? Positive up, negative down. And that's VC. Required to get positive up, negative down. Voltage, Kirchhoff law. You will take this as a reference, VC. And then the positive is connected to the positive will be minus VD equal 0. So VC is equal VD. And what's VD? For voltage. I want to show you it's very simple. When you look at the problem here in the beginning, you think it's really hard one, but it's not hard at all. It's easy, but it depends on how your understanding of Kirchhoff current law and Kirchhoff voltage law. Okay, let's move ahead. Find the currents and the voltage. Okay, this is very similar to the problem I gave it to you. Well, to do that, first you have to find the equivalent resistance of the whole thing. So you can apply Ohm's law. You can represent the whole thing by only one resistor. Okay. Well, this resistance and this resistance in parallel. True, because they are connected in parallel. They have the same voltage apply, and the current divided معناها in parallel. So I find first the R equivalent one for 9 and 72. I will say is equal to 9 times 72 divided by, and then find the value. For example, if you just call this R1, R2, R3, so this is your R, which is R2 and R3. That's the equivalent of R2 parallel with R3. Now we can replace this 2 parallel resistance by one resistance by the value we got it here, which is called it, for example, R4. So you have now R4. You calculate by the calculator, just so you can study the lecture while you are doing, and you got here R1, which is equal to 2 ohm. So R1 and R4 now in series. So now we have the R equivalent will be equal to R1 plus R4. 2 plus R4. R4 is known. It's known, just calculate. Okay. You got R equivalent. After you got R equivalent, now we can find I, the total current. I is equal V, which is equal 9 volt over R equivalent. 9 volt over, you put the value here after you calculate. Then you get the value in ampere. What is this current? The current coming out of the source, which is I total. Then if you want to find the voltage here, you got to find the current here also. How you find the current here? If this is I1 and this is I2, now we can use the current divider. I2 is equal the total current that you got it times the resistance, the opposite resistance, which is 9 ohm, divided by the total 9 plus 72. And you got the current. You got the current. So work this problem. I give you the steps to do it. And somebody is telling me, but we need to find the voltage. It's easy. The voltage you multiply I2 times the R3. And R2 is 72. And I, whatever value we got it, that's the voltage. Everything. You want to find I1, you say I total times 72 divided by the total, and that's the current, I1. You want the voltage here, it's the same. You don't have to calculate it. There's an easy way. Once you find the voltage here, the same voltage here apply to this one resistor. You can divide the voltage by 9 ohm, you get I1. Okay. So that's part 2. And I hope you go through the lectures, and I'm going to post some problems, you think about it, and then we're going to solve it in the lecture together. Okay. Have a good day.